Sports drinks like Gatorade are advertised to contain electrolytes. But what exactly are electrolytes? And how should we think about this term when we relate it to solutions? When we think about solutions of electrolytes, we can define an electrolyte as a material that can conduct electricity when dissolved. For a material to conduct electricity, it must have charges that are free to move around. In the copper wiring in your home, the mobile charges are simply electrons that can move through the band structure of the solid. For a solution to conduct electricity, it must also have mobile charges, in this case, not electrons, but ions. When sodium chloride dissolves in water, sodium ions and chloride ions are formed. What we'll find is that ionic compounds will be considered strong electrolytes. 100% of what dissolves goes on to form ions. Sucrose, the common form of sugar, is a covalent compound made up of carbon, hydrogen, and oxygen, all nonmetals. When sugar dissolves in water, it stays as intact neutral molecules. There are no ions that form. Sugar is what we would call a non-electrolyte. It does not form ions. But how can we actually know if ions are formed? We can use what is called the light bulb test, shown here from a figure in our textbook. A circuit is plugged into the wall, which is our power supply, but it's not a complete circuit. Two electrodes come from the power supply and are placed into a solution. If there are mobile charges that can go between the electrodes, then current can flow and the light bulb will light up. If not, the bulb will stay dark. We've got our equipment to do the light bulb test. Got a light bulb with two wires coming out the bottom, a little hard to see, but they're there. Got a cord to be able to plug this in. Got some sugar, got some salt, and of course we've got our water. And it's important to use distilled deionized water because we don't want any ions in here to begin with. We've also got a little magnetic stir bar. It's a magnet coated with Teflon. I'm going to put that in there just to help us stir up the solids that we're going to add. So what we'll do, we'll put our water in here. Okay, let me turn on the stirrer. Looks good. We'll plug in the light, and we're ready to add our solids. We've turned off the lights to hopefully see the bulb a little bit better, so we'll start with some sugar. Notice the bulb right now is dark because it's simply in the deionized water with no ionic content. I'm going to take some sugar, put in a pinch of sugar and let it dissolve. And do we see anything with the light bulb? No, not really. Okay, but this is not unexpected, right? Put in some more sugar here. Not unexpected because sugar, we know, is a covalent compound. We don't expect any ions to form when sugar dissolves in the water. Well, put the sugar away. Let's try some salt. Of course, we don't really know that this equipment is working. Could be that the equipment is broken. Could be the light bulb's burned out. Don't know yet. Let's take a pinch of salt, put that in, take just a minute to let it dissolve, and let's see if we can see any light from the bulb. Just the slightest little bit coming on. Now I'm going to put a little bit more salt in here. I don't know if you can see it. The bulb is just starting to light up a little bit, and as more salt dissolves, the light is getting brighter. Let me put in some more salt. As we do that, the bulb gets brighter and brighter. So this light bulb test is really a test of the ion content that's dissolved in the water. What the experiment shows is that if no ions are formed, the bulb stays dark. If ions are present in solution, The more ions there are, the brighter the bulb. So the light bulb is an indicator of how many ions are present. The experiment itself reinforces our model of dissolving an ionic compound. We have individual ions, each surrounded by solvent molecules that are free to move through solution independently.